All right. Well, hello and welcome to another DevNation Tech Talk. I'm excited to have all you folks here today. Hopefully you're excited to be here. We actually have a very special guest with us today. Eric Murphy is going to rock and roll with TensorFlow and Quarkus. And if you've not heard TensorFlow, then you've probably not been paying attention for a while because it's happening in the ecosystem. People are super excited about the open source TensorFlow project and what you can do from an artificial intelligence and machine learning perspective. And Eric is going to show us how to make that magic run with Java, with Quarkus, and he's got a really awesome demo, so make sure you stay tuned to the end. We're going to hand you a special URL, and we're going to have you guys help us out a little bit. But Eric, we'll turn it over to you.
Thank you, Berg. So let me share my screen here, and I'll jump into the presentation. So today we're going to talk about going deep learning with TensorFlow and Quarkus. And so my name is Eric Murphy. I'm the practice lead for Red Hat runtimes here at Red Hat. It's a new role for me. So today we're going to talk about some brief introductory content. And then, as Berg mentioned, there is a demo application. I call it Tensors and Quarks, and there's an audience participation component to it. And then we're going to go deeper into the whys and hows of TensorFlow with Quarkus and end up with some Q&A, time permitting. So I urge you to open up a new browser tab. Be ready, because as Bert said, you're going to get this URL. I want you to go out and see the demo application, and if you want to, participate. So first, I want to talk about a dire business need that we're seeing with our customers, where they have mountains of data that they are collecting, and they're not really using it, and they're looking to build data-driven solutions. And this is where building more intelligent applications comes into play, where you're bringing AI/ML into the fold. And so in order to build these intelligent applications, what you need to do is you need to combine machine learning with traditional programming. And with traditional programming, you have these rules, meaning code and business logic, that you're combining, with some set of data. And you're running this application to get a set of concrete answers, right? But with machine learning, the paradigm shifts, where you are giving this machine learning algorithm the answers and the training data up front, and at the end, you're getting these rules or these inferences coming out. So this is an inversion, and so the applicability for machine learning is very narrow scope, and that's why you need to combine it with traditional programming to build these intelligent applications. Excuse me. And so these rules, they can be compiled into a machine learning model that can accept new data and give you back predictions. And so what you need to do is train a machine learning model that acts as a function. This function has a set of inputs and outputs, and you can actually publish this machine learning model to make it consumable by others. So that's very exciting. And so, when it comes to machine learning and also deep learning, let's talk about, TensorFlow. What is it? Well, it's an end-to-end open source machine learning platform. It has something called a stateful data flow graph, and that's where all the computations happen with TensorFlow. And a tensor is actually a generalization of vectors and matrices inside of that stateful graph. And TensorFlow is typically used by data scientists to build machine learning models. They typically use Python code, and they can actually save these models out as a file or directory and have them be consumable by others, including developers. And you do not actually need to be a TensorFlow expert in order to consume these machine learning models from TensorFlow. And another point I want to make too is TensorFlow is really great in that it's friendly to both GPUs and CPUs, so you can potentially deploy these machine learning models to commodity hardware. So let's talk about serving machine learning models with Quarkus and TensorFlow. So this is what typically happens, where you're saving out this machine learning model and you're serving it up with maybe TensorFlow serving or a Python microservice, and it's accepting HTTP requests, with some data, and it's returning back some predictions in its HTTP response. The paradigm I'm showing here today is actually taking that machine learning model and bundling it with your Quarkus application. And so Quarkus is actually handling the HTTP request and passing that data into the model, retrieving the results and passing that forward in the HTTP response. And this also fits into like a message-driven architecture where maybe you're using Kafka, right? So instead of HTTP, you can actually pass messages in and messages out with the predictions. And so it works both ways. And so now I'm going to jump right into the demo and show you what I built here. So this is the Tensors and Quarks application. So this is a Quarkus application. It has, HTML user interface. And it has a variety of links here on the left that will allow you to download images that you can actually upload down here at the bottom right. And so I'll walk through some instructions on how to do this, but first I want to show you some images that I already have saved off. So the first image I want to show is just a dog. So we have a dog here. If I mouse over the label, I can see that there's a confidence score of 98.65%, and you can see in the red the actual boundary box around that dog. Okay, so I'm going to try a few other images here. So next one is a keyboard. So you can see the keyboard, it's very confident there, 97%. Next image is 2 toothbrushes. So there's multiple objects being recognized here. So we have 94% and 83% confidence on these toothbrushes. And it's probably catching the bristles on this one. The bristles are bigger, that's why the confidence score is higher on that one. So the next image I'm going to show is actually an animated GIF. I threw this in here just for kicks. So it's a dog riding a turtle. And so what this does is it takes the first frame out of the animated GIF and it sees the dog in there, but for whatever reason, it does not pick up the turtle. The next one I want to show is a very interesting one. It's a family riding bicycles. And so the model here is recognizing that there's 4 people here, right? But it's making one mistake. These machine learning models, they're not perfect, right? They're making predictions. There's a level of confidence involved, right? And so if I mouse over this one right here, it's highlighting this small child's bike here, and it's 88% confident that's a motorcycle. And so I think the reason why that's happening is because the tires are smaller and thicker, right? And so those tires look more like motorcycle tires rather than bicycle tires. So I think that's why it's thinking that's a motorcycle. So that's kind of interesting. And the next one I want to show, the last image here, is a horse, right? And this is actually a horse that is wearing clothes, it has a hat, it's kind of a confusing photo, right? But still, that machine learning model is picking it out as a horse at 82.52% confidence. So, that is a little bit lower, but I set a threshold on the confidence at 65%. So I'm going to step out of this demo and go back to the presentation. Okay, so if you want to, you can go to getquarked.com and then notice the links on the left there, okay? You have to use these links, other images will not work, right? And here you can actually download sample images, right? And so all these links on the left actually align to what the machine learning model supports for the actual labels, right? So you have to use those links. So download the image, right? So after you download the image to your computer, you have to actually upload it again, or upload it up to the application, right? And so the application will read in that image, and it will return a response back for you. And this can take up to several seconds under heavy load, so please be patient. And I can already see that some people are uploading images, so that's great. You guys figured it out already. So how does this work? Well, the TensorFlow project, they actually publish Java libraries for the TensorFlow API and the underlying C++ libraries. And you need to use JNI, the Java native interface, to link that library to Java. And this TensorFlow model is actually loaded into the Java application memory space. This is a self-contained executable, right? And data is sent to this TensorFlow model as a byte array. This is very low-level data, and the result can be returned quickly. And that allows a request-response type of serving model. And so the model that you're seeing here today, this object recognition model, that typically returns results in under 200 milliseconds. And also Protobuf, if you're familiar with Protobuf, that is actually used to convert this raw data from TensorFlow into Java objects. It's used to read the model itself. And as a bonus, the Graal VM native image compilation supported by Quarkus also supports JNI. So this demo application that you're using is actually a native executable. It's not running on the JVM. It's a native executable that's running, that incorporates this machine learning model. So that's very cool. So this diagram depicts how this application actually works, and I'll walk through this. It's a little complicated, but I'll walk through it. So if you start on the left here with a web browser, you're user one, right? And so you're uploading an image into this application. It's a multi-part form upload, and the application reads in that image, and it does two things with it. The first thing it does is it puts it in an image cache, because these images, they have to be retrieved by other users, so they have to be downloaded. So it goes into the cache, it resides there for about 30 seconds. And the other path it takes is this image is converted into byte arrays, okay? And this is actually the most CPU expensive part of this flow. So I ran some profiling on the application, and like 75% of the CPU time is spent on converting this image to byte arrays of RGB values, okay? So then that image byte array goes into the TensorFlow model, and you receive back 3 byte array results, which are essentially a confidence score, a label, and bounding boxes for each of the objects that are identified in that image. And that image is converted to a Java object where Protobuf comes into play. And then I take that Java object and I actually publish it. I publish it to the Vertex event bus, if you're familiar with Vertex. So if you subscribe to that event bus, you're going to receive that Java message. And so under the covers, this application, the TensorFlow application, it connects to a stream of server-sent events. This is not WebSockets. It's server-sent events, it's HTTP, and it's reading the data back as JSON coming off that Vertex event bus. So it's a really cool implementation on how this works, right? And then once your web browser receives that result, it actually will use a unique value, a key, to make another HTTP request to download that image out of the cache. So functionally, this is how this application works. Okay, so now I want to talk about, why you would want to serve TensorFlow models, from Quarkus. So in serving these TensorFlow models, there's a definite, business case here where, you can use these proven enterprise technologies such as Java to deploy these machine learning models. You're not dependent on, Python, for example. Java is known to be, better performing, more enterprise ready, right? And you can leverage your existing developer talent, and you can build these intelligent applications and bring that machine learning into the fold with these models. And also, there's a huge open source community around TensorFlow. There's freely available tools and model and data that you can use to get up and running quickly without having to be an expert. Also, you can bridge your data science teams with your development teams. And also, you have a lot of flexibility with your hardware. You don't have to purchase a GPU in order to use TensorFlow and serve up models. And so that's really cool. Also, from a technical perspective, Java is generally higher performing than Python. There's a huge ecosystem around Java. And then with Quarkus, there's numerous extensions that you can utilize to build these intelligent applications. So you can combine machine learning with Kafka and have these streaming data pipelines. You can combine it with a new project called Cogito for business automation, and use OptiPlanner for AI constraint solving. You can use the InfiniSpan for a data grid. You can go reactive with Vertex and a new API called Mutiny. So that's what I'm using here for that event bus, right, as I mentioned. So really cool stuff. You can build really intelligent, meaningful applications using Quarkus with TensorFlow. Also, you can deploy out to Kubernetes and OpenShift, using a proven runtime. Quarkus, it's meant to be container ready, right? It's meant to be deployed in Kubernetes. And so that's a huge advantage, right? And also, GPU acceleration is possible. I haven't touched it, but there is a TensorFlow Java library that supports GPU acceleration. So that's something that could be worth experimenting with. And so what are some of the use cases here for using TensorFlow? Well, image recognition, processing, that's where you're talking about neural networks, and that's pretty much what this inception model is that I'm using. So this inception model has been around for a while. It is neural networks. And additionally, you might want to utilize, human language related features such as sentiment analysis. So that's where you take a piece of text and you can analyze whether it has a positive tone or a negative tone. You might also want to incorporate data analysis, behavioral predictions. A good example of that is fraud detection, right? Where you're detecting, these outliers in your data. And there's so many creative machine learning solutions that are documented in white papers and open source projects. And so there's no need to start from scratch with any of this. There's a huge community. And then you can combine all this with the power of Quarkus. It's really compelling. So some additional information that I have for you is some of the performance benefits around using Quarkus and TensorFlow. So if you're using the native image compilation, you potentially could have scale to zero serverless deployments of TensorFlow and Quarkus. It is dependent on the machine learning model that you're using, how fast that loads. But if you use the native image compilation, Quarkus starts up in like a small fraction of a second. Additionally, you can reduce your memory consumption. And so with a cold start of this application, it uses like 800 megabytes of memory. That's pretty compelling considering a lot of other Java frameworks, you're looking at over a gigabyte right out of the box, just with a hello world, maybe a RESTful web service, and, potentially a data access API. So this is very lightweight. Also, you have the ability to scale out to potentially hundreds of machine learning model deployments across a Kubernetes or OpenShift cluster. And so me personally, working at Red Hat, I've run across customers that actually have hundreds of different machine learning models that they use, right? But they don't have the ability to really deploy those and use those as a microservice architecture, right? So this helps solve that issue, right? Additionally, for some of our customers, deploying at the edge is important, right? And so with this, you have a self-contained deployment, right? You have that model contained within the application, right? So you don't have callbacks to some backing service or some data center that's necessary to deploy this machine learning model. You can do it all at the edge, right? Also, I encourage you to check out the links that are on the top right of the demo application. So these are links about information for AI/ML on OpenShift. As we know, AI/ML is very hot right now. But I will say, working with AI/ML on OpenShift of recent, it's really awesome. You can do things that were never possible previously. And we actually sponsor a project called Open Data Hub, and you can check it out at opendatahub.io. And so this provides a blueprint for running AI/ML applications on top of OpenShift. And there's an operator-based installation of AI/ML components such as Jupyter Hub, Kubeflow. You can deploy an Apache Spark cluster, many other components that you might need to build AI/ML, machine learning models, intelligent applications, et cetera. And also, you should really aim to have these workflows around AI/ML, and you can do this completely on OpenShift. So it's very compelling stuff. Check out those links. And so to wrap things up here, I do have some additional information for you. So there is a GitHub project out there that you can go and look at. So this demo application is freely available for you to take a look at. As I said, it's written in Quarkus. It compiles to native image. It uses TensorFlow 1.15. The model is included inside of that project. So feel free to check it out. To reach out on Twitter and follow me. And also, I will have a blog post that's coming soon that will dive deeper into how this works, including the code. So, this presentation is more of an overview. So, definitely want to give you those technical details here in the near future. So, with that, I'm ready to move into Q&A.
Yeah, we do have some fun questions for you, Eric. And so there's one that Chris Weiss asked that I think we'll start with, and that is, there is a two-step process here. There's the training of the model, and then there's the inference side where you're just executing the model. I think you were focused on, the execution side, but can you talk a little bit about training models and what you might do there?
Yeah, so that's where Open Data Hub comes more into play, where you can actually deploy Jupyter Hub out on top of OpenShift, right? And so you can establish these workflows for your data scientists to bring data in and build these notebooks, right? These Jupyter notebooks, and to train a model, right? And if you're using TensorFlow, you can use the TensorFlow APIs. There's an API called Save Model, right? And that actually takes your trained model and save that out into a file or a directory that can be imported and run inside of that Quarkus application for the serving and the inference aspects to it. Does that make sense?
Yeah. And then another question related to this is, can this be run in an OpenShift, in containers? And if so, how many containers might you use? Or can it be run on a RHEL, a straight up RHEL? So can you give us some more aspects of how it might be run, executed?
So you can deploy this in multiple forms. So you could run it just on a virtual machine on RHEL. So you can just use a JVM deployment, or you could even do a native image Linux executable deployment of the application onto a VM. You surely can deploy it in containers, either on the JVM or as a native image. Or you could even go a little bit more on the cutting edge. You could deploy it in Knative and go serverless. And that would give you some intelligent scaling options as well, where you're more effectively able to tune it. Yeah.
Yeah. So the Knative idea came up also, and there's a kind of a related question to this: is if I do deploy in containers on OpenShift, is it a single container, or how would you architect your overall application? You had your architecture diagram earlier. Would there be multiple containers representing those components, or a single container?
Okay, so for this demo application, there is only one instance of it running, right? And so you could theoretically do load balancing of this application, right? So you have different instances of the application that have this model self-contained, right? And so they're serving up the model independently in a load balanced way. Or you could implement a microservices architecture where you have these Quarkus microservices that are backing services that are serving up these models. And so if you have multiple models that you're serving, each one may reside in a separate microservice, right? And then you may have some sort of API entry point into your microservice system that calls these backend services. So you have multiple options here.
Right. Because it was Chris had another question related to, what if I had to do a complex analysis? Could I chain models together? And I assume what he means there is, if I had, let's say, 14 inference engines, I could chain them together in a microservices way. Call one, which gives me a result, call another, gives me a result based on that result, call another. Have you ever explored anything like that, trying to chain these things together?
I have not gone that far with it yet, but you could potentially deploy multiple models inside of one application. So if you need really high performance, if you want to eliminate the latency associated with microservices and distributed systems, you could definitely do that, or you could deploy them independently as well. Another thing you might consider implementing is like a rules engine around this, right? So you're getting these inferences, you're getting these scores back, right? But then you might need to do something else based off that data, right? And so you may want to respond to different scores in a different way, depending on what they come out to be.
And if you look at our last three keynote, this year's keynote demo coming up in 2 weeks' time, and the last 2 years of keynote demos, we had a very similar kind of architecture where we ran the inference engine, got the scoring done, right? Oh, that's a toothbrush or whatever we were looking for. Sometimes this year we have finger painting, so you draw a numeral with your fingertip. Last year was vibration, we were sensing vibrations. So basically the inference engine would come back with what it thought the answer was, and then you have another microservice or two or three that respond to that, right?
Mm-hmm.
You decide what to do with that information.
Right.
Another question, though, and this is more of a generic TensorFlow question that was early on in the session that you should respond to, and that is, what is TensorFlow? Is it a Python library? Is it a service? Is it software as a service? What is TensorFlow? Can you kind of describe that a little bit more?
So TensorFlow is not one thing. There's a whole community around it, right? But TensorFlow, like as an underlying library that is written in C++, and so that's actually what is loaded in with the Maven dependencies is this TensorFlow library, right? And so that's actually what is used to load in the machine learning model and serve it. Okay, so there's that aspect to it. But also there is an API for TensorFlow that is used by data scientists in Python. There are different components of that API. So, for example, Keras. So that allows you to define, what a model looks like essentially for TensorFlow. And there's many other Python libraries that can be used in your Jupyter notebooks to build these models in conjunction with TensorFlow. So there's a whole community around this. If you look at different implementations of basically the same model, you can get wildly different implementations using different libraries, different tools, but effectively the same results.
Right. Well, I love what you did with the image classification. I mean, that's a pre-trained model. You didn't have to train it yourself, right?
Mm-hmm.
Yeah, so that's nice.
Yeah, there's all these pre-trained model. Yep.
Right. It's nice to have pre-trained
model, so I could just. Yep. Exactly.
Yeah, and related to that, someone wants to know, did you use TensorFlow 2 or TensorFlow 1? TensorFlow 2?
This is using TensorFlow 1.15, which is the latest version for Java. And so the TensorFlow 2 for Java has not yet been released. Hopefully that'll happen sometime this year. But for now, TensorFlow 1.15 is definitely sufficient because TensorFlow 2 is new and there's not many models that have been written.
Okay. And just so you know, people went crazy on the uploading of images, including the cat underneath the covers, which I love, by the way, the panda bear, though it did actually think the soup was a Frisbee. There's some really great stuff that it actually, when people uploaded their images, just so you can go look and see for yourself. But one thing also I want to make sure people know is we're actually going to run several more of these AI/ML sessions starting in June. So we actually have data scientists who are going to join us on DevNation Tech Talks. Are going to show us what they do with their Jupyter notebooks and how you can run that at scale, let's say in containers. We got a person who's going to specialize on GPUs and what that means, running that within a container as an example. And so we have 4 sessions lined up for early June. So June 4th will be the first one, but pay attention for that one. We have several AI/ML topics that'll be a lot of fun. There was a question from Michael related to OpenStack. Have you heard of anybody running this sort of thing with OpenStack, or is there any concerns running with OpenStack?
I'm not aware of AI/ML OpenStack workloads, but I will say that if you're looking for the GPU enablement with virtual machines on OpenStack, that is possible. So I think that would be attractive for somebody that actually is using OpenStack that has very heavy-duty AI/ML workloads they're looking to run to have that GPU enablement. But otherwise, I really don't see any issue in doing that.
Okay. Another question about deep learning.
I see TensorFlow as kind of the default, solution for deep learning. It is very popular. And the thing I love most about TensorFlow is there's a huge community around it. There's so much that you can use just for free off the shelf that it makes it a really compelling option. That being said, there's always new and upcoming technologies that you need to keep an eye on. And also, data scientists, they typically use Python. They don't use Java, right? So you want to veer towards Python-oriented technologies for data science.
Yeah, definitely the data scientists themselves will produce models done in Python, and then you would have to get that model and run it. Okay. But Luis was asking about that DL4J. He is already using it with some of his applications. Just kind of wanted to know what your experience was. And obviously you've not encountered it or worked with it, so that's what it is. Yeah, fantastic. Okay. Well, thank you guys all for your time today. Saw lots of questions, lots of responses. Thank you all for that. We're unfortunately out of time. Eric, awesome stuff from you. Thank you so much for that. All right. Well, everybody have a great day, and we got to sign off. And if you have further questions, hit Eric up on Twitter, or you saw the email address. The slides will be updated on the link that you're sitting on right now. We'll give us a little time for that, and that'll be there. And you always have my email address if you guys want to reach out to me. Thank you all so much. Have a great day.